Hello all, here we have captured the DHT11 sensor data and let us see how the communication is happening between DHT11 and the host. Here host is Raspberry Pi for us. So if you see here, the first communication initiation happens from the host where host sends the low data for a period of around 18 milliseconds as per the requirement. Now we have 20 milliseconds here. So 18 milliseconds is the minimum. So post this, host will send one high data as well, which can last up to maximum of 40 microseconds. Here there is 13.5 microseconds. Now, once these two data is sent by the the host can wait for data from the DHT11, and that is where the DHT11 starts communicating, and immediately the line will be pulled low. So if you see the communication between data DHT11 and the host is a single wire interface. It's only a one wire. Okay, so now in here what happens is once DHT11 is ready, it pulls the signal low and keeps it low for around 80 microseconds. Okay, and then post that it pulls the data up and keeps it for around approximately 80 milliseconds. So these two is an indication that the DHT11 is ready to communicate, and then post that the data will be transmitted. So post this, whatever we see here, this is the entire data. Okay, so this data is a total of 40 bit data, and if you see here, approximately if you take 3.5 to 7.5, it is existing for a period of around 3 to 4 milliseconds. Okay, so this 40 bit data which is in this entire timeline has the temperature and the relative humidity data, which is around which is actually a decimal data. So for that, the first 8 bits, okay, here will be integral relative humidity data, followed by 8-bit decimal part of that relative humidity data, and post that it will be 8-bit integral part of temperature data, and post that 8-bit decimal part of the temperature data. Decimal, like example, in our applications, in our temperature, we have shown 28.0, 28.1, 28.2. So the decimal part will be followed by uh, uh, the integral part comes first, and then it is followed by the decimal part, and finally the 8-bit will be a checksum data. So that means two 8 bits of humidity data, two 8 bits of temperature data, and then the checksum data. So comprises 40 bit data. So this is how the entire communication happens, and post that the data line will be high until again the host pulls it low, requesting for data from the temperature sensor. This is how the entire communication data happens. So this is captured in the logic analyzer to explain to you how the data bit stream is.